Let's do some learning checks. I would like you to try these on your own, pause the computer, and then come on back and check your work. For a normal distribution with a mean of 80 and a standard deviation of 10, find each requested probability value. So we don't know what these scores mean for these learning checks. We're just looking at different numbers in relation to a normal distribution. So the first letter A is asking you for the probability of finding a score that is greater than 85. So let's start with that one first. Let's map out first what a z-score would be for 85 and then figure out what this item is asking us to do. Once again, here's our notation, the probability of finding a score that is greater than 85. The mean of our distribution was 80, the standard deviation was 10, and the score we're looking at is 85. I already know just looking at it, this is greater than the mean. That's going to tell me something. But the first thing I'm going to do is I'm going to find the z-score. So my score is 85 that I'm interested in. 85 minus the mean of 80 divided by the standard deviation of 10. So that gives us 85 minus 80 is 5 divided by 10. My z-score is a positive 0.50. I knew it was going to be positive because my score is higher than the mean. But anyway, what is it asking us? It's asking us for the probability of finding a score in the distribution that is greater than a positive 0.5 for a z-score. So let's map out and see what that looks like. I locate my z-score of positive 0.50. It's halfway between 0 and 1. Is that correct? So positive 0.50 is there. And we were being asked to find all of the scores greater than this particular z-score. So I'm going to go ahead and shade this in. And now I'm going to have to figure out which column am I going to be using. Column B, C, or D? Well, basically I'm looking for everything in the tail region. So that should give you a bit of a clue as to what column we're going to be using. Let's take a look. Now we know we have a z-score of positive 0.50. We have a sense of the fact that we're going to be looking in the tail area. So we look in column C and we find a proportion in the tail of 0.3085. So I can interpret this by saying that if I have a z-score of 0.50 or if I have a raw score of 85, the probability of selecting a score higher than that in the distribution is 30.85%. Let's take a look at this next one. We're looking for the probability of finding a score in this distribution that is less than 95. Let's find the z-score and then map out what it means to be less than 95. With the score of 95, we're looking at the probability of finding all of the scores less than that. Again, we have all the pertinent information. Let's go ahead and find the z-score for 95 first. 95 minus our mean of 80 divided by 10 gives us 15 divided by 10, or a z-score of a positive 1.50. So our question is, what is the probability of choosing a score that is less than a z-score of positive 1.50? Let's see what this looks like. I can locate my z-score of positive 1.50 somewhere between a z-score of 1 and 2. And what were we being asked again? We were being asked to find all of the scores that were less than this z-score. So I'm going to draw this area in here. And we are looking for all scores less than a positive 1.50 z-score. We're going from a z-score, we're crossing the mean, and we're going to the tail. So let's take a look and see what column we're going to use on the unit normal table. So our z-score we found was positive 1.50. We're looking for everything less than this positive score, and we mapped out and saw that this crosses the mean and goes to the tail. So we're going to be looking at column B for the proportion in the body, and we find 0.9332. We can interpret this by saying that the probability of selecting a score less than 95 in this distribution is 93.32%. That tells me that a score of 95 is really quite high, and it has a z-score of 1.50. Here's the last one we're going to do before we do one more that's a little bit more challenging. What is the probability of finding a score in this distribution that is greater than 70? Let's find the z-score for 70, and map out what it means to be greater than 70. So we're looking for the probability of a score that is greater than 70. We have all the information. Let's find the z-score. 70 minus the mean of 80 divided by 10 gives us negative 10 divided by 10. So our z-score in this case is negative 1.00. We're being asked to find the probability of selecting a score greater than a z-score of negative 1.00. Let's see what this looks like on the normal distribution. We can locate our z of negative 1 right on the negative 1 line here. And once again, we were being asked to find the probability of selecting all scores greater than a negative 1.00. I'm going to shade in the area of interest, and then I'm going to think about whether I'm going to look at column B, C, or D. I am taking a negative z-score, I'm crossing over the middle and going to the tail. So that tells me which column I'm going to be looking at. So when we're looking for a score that is greater than 70, we ended up with a z-score for 70 of a negative 1.00. And what we were looking for is everything greater than that negative 1.00. So we're looking for the proportion in the body. Because negative numbers are below the mean, if we're crossing over the mean and going all the way to the tail, we're looking at column B. And how I can interpret this is that a z-score of negative 1.00 has 84.13% of the scores above it. Or in other words, in this distribution, 84.13% of the scores were higher than 70. All right, we're going to do one more. We have the same mean and standard deviation, but this time we're going to find the probability of finding a score between 75 and 100, or a score that's greater than 75 but less than 100. So we're going to have to find two z-scores, right? One for a z-score for a raw score of 75 and one for 100. Let's do that and then map it out. The first thing we're going to do is we're going to find two z-scores, one for 75 and one for 100. So I'll do the first one first. 75 minus 80, the mean of 80 divided by 10. That is negative 5 divided by 10. So our first z-score is equal to a negative 0.50. The second z-score for 100 minus our mean of 80 divided by the standard deviation of 10 gives us 20 divided by 10, or a z-score of a positive 2.00. Now what we were being asked is, what is the probability of selecting a score between 75 and 100? And we turned it into, what is the probability of selecting a score between negative 0.50 and 2? Our first z-score was negative 0.50, so I'll locate it at about here. And the second z-score was a positive 2, and I'm going to put that about there. Now, let's see what columns are going to be helpful to us as we look at our unit normal table. Well, what I can do is I can find the proportion between the mean and a z of 2, so I'll go ahead and shade this in. That's the first proportion I could find. And then I could also find the proportion between the mean and the z of negative 0.5. And if I add all of this up together, I'll get the total probability of finding a score between negative 0.5 and a positive 2. So let's look at the unit normal table. So our lower z-score was a negative 0.50. And that gives us a proportion between the mean and the z that we mapped out of 0.1915. So that's part of the equation here. Our second z-score, the higher z-score, was positive 2.00. And again, we were going to look for the proportion between that z-score and the mean, and that gives us 0.4772. Now we know both proportions. Let's take a look at them together. So what we can do then is take these two proportions that we previously found and just add them together. And I'll do that very fast. And we end up with a proportion of 0.6687, or I can interpret it by saying that 66.87% of the scores are between a score of 75 and 100. That's it for this video. I know it's been a long one. We've got one more to go where we're going to do some more examples. I'll see you there.